Hello, everyone. Is the mic on? Perfect. Thank you for coming to this. We're going to catch up with what's happened with C# over the past few versions. Everything that's happened from C# 9 up until 14. I won't be going too much into details on everything that's coming in 14, because there's a session tomorrow morning from Mads, who works on the language design team, who will go through in detail about everything that's coming in C# 14. But I'll give you a quick roundup of what's coming there as well. My name is Filip Ekberg. I love talking about C# and .NET. I'm always happy to answer questions about how C# works, how .NET works, and how some of these language features work. So if you have any questions afterwards, feel free to send me an email. All right, so C# has changed quite drastically over the past 20 years. It's not looking nearly the same as it did in C# 1, 2, or 3, and there's a lot of language features being added with each iteration of the language. Some of these change fundamentally how we build our applications, like async and await, generics, pattern matching, and some of the other stuff that we're going to look at here today. They really change how we build our applications. The whole idea is that we build applications faster with less errors, like less error-prone applications. So we're going to see how we can do that with some of the additions to C# and .NET. But before we do that, I'd like to know, how many of you have heard about LTS and STS versions of .NET? About all of you, right. So who's waiting for an long-term support version before they upgrade? Almost the same people. At least half of you raised your hands. So the thing with this is, every year Microsoft releases one new version of .NET. Every second year it's a long-term support version, and the year in between it's a standard support version. Some people think that just because it's a standard support version, it's not as good, or it's including experimental features, or it's not as stable, but that's not really at all how this works. The only thing that this really bad naming refers to is how long Microsoft supports the release of that .NET version. So why am I talking about .NET versions? Because when they ship .NET, they also ship a new version of C# and the compilers, which includes bug fixes and memory improvements in both the APIs as well as in how the language works. So if you upgrade with every version of .NET, you get the most stable .NET possible. You don't have to wait until there's a long-term support version. Now, I get that it's a little bit of a costly process of upgrading. You need developers, and you also need to test your application. So I get that everyone can't just upgrade out of the box. But try to, and in November this year, we're currently on .NET 9, which is C# 13 and .NET 9, they come together. In November this year, we're going to get .NET 10 and C# 14. So I do encourage you to try and upgrade to that as soon as you can. Now, with that being said, there's one really interesting problem that's been surfacing for a long time. How many of you have seen this happen before? All right, half of you raise your hands, the other half are liars. I think all of you have seen this before. At least I suspect so, or you will see it in the coming weeks or days. Null reference exceptions are really a big problem in any applications. You reference something that could potentially be null, and the application crashes, or you, fortunately enough, might catch it and hail that exception. However, what if there was a way for the compiler to tell us that this could potentially be a problem before we even run the application? So this is where they introduced a feature called Nullable reference types. This completely changes how the compiler looks at everything that's a reference type. So when you create a class, the compiler looks at this reference type and now thinks that this should never be set to null anywhere. Anything that's a string, everything that's an object or a reference should always have an instance. And if it doesn't, the compiler will tell you that you're probably doing something incorrectly. So if we jump over to Visual Studio, I'm in the latest version of, or the insider build of Visual Studio, which looks a little bit different if you haven't seen it before. I have a simple .NET 10 application, but again, this is an older language feature. It was introduced in C# 8. So you've been able to do this for a long time, but they've continuously improved upon it. So it doesn't really matter if I'm on .NET 10 or 9 or 8. This will work either way. So what this is doing now is that it looks at all the different references that I have here, all the different reference types. So if I expand my details class, Now what the compiler is doing is that it's looking at my references that I have inside my class, and it's trying to determine, can I guarantee that you've set these to an instance? It will give me a warning telling me that you haven't set this to an instance. You should probably ensure that this now non-nullable type should be set to a reference or should be set to an instance somewhere. There are a couple of ways to solve this. Either we ignore the warning, which is not a good idea. We can introduce a constructor which changes the contract, so anyone that's now using this class have to change the way they consume it. So if I just introduce a constructor, notice how the warning goes somewhere else. The compiler will now determine that the constructor should be in charge of setting these two non-nullable types to an instance. So of course, what I can do is that I can start adding parameters here, first name. I can also add string last name. And I can set first name, not that, and last name to that. And now we have gotten rid of all the warnings inside this class here. But this isn't really great, because now I had to change my contract. Anyone that's using this will now have to change their usage as well, which is not really great. So what else can we do? Well, we can use a newer feature in C# that allows us to determine that I'm required to specify this, and I can also determine that something is optional. We've always been able to determine that something can be optional by using a question mark. For example, now I'm saying that last name is optional. There's no longer a warning in here. So where did that warning disappear? Does this mean the compiler will no longer be able to detect potential null references? The idea here is that the compiler should be able to track the null state. It should be able to track where could this lead to a null reference exception. Would this have caused a null reference exception? Probably not. Where this would cause a null reference exception is where we access last name. And now we've moved that warning to somewhere else. But let's get back to that in just a moment. What I can also do is that I'd like to be able to say that first name is required, so why not use that keyword? There's a required keyword that now determines that you have to specify this when you create an instance. If you don't have a constructor, then those that consume this and create an instance, they most certainly use the object initializer. Now I have to specify first name in that object initializer. So I no longer have any warnings in here, and the compiler will try and track where this is used elsewhere in my application and determine if this has been set to an instance. So if I continue to expand my application, I can see here that I have another reference type here. I have this a property of this details class that I'm also going to say this is required. And again, neither of these two places were where the null reference exception would have occurred. But if we scroll up a little bit more in this application, I now expand some of the code in here. Look at this here. I have a for each loop that iterates through a collection. And what's interesting here is that I have determined that this is going to be a non-nullable collection. I could have said that this could potentially be null. It could potentially contain null object as well. But we really don't want our applications to end up having question marks all over the place, because it becomes quite difficult to read. So let's undo that. And instead, also notice actually, if I redo that, notice how it tells me that I should probably null check it before I run this with a for each loop. So we get a warning here saying that this could be null and this could lead to a null reference exception. But when I remove the question marks, it's now sort of determined that the compiler trusts that this should be set to an instance somewhere. However, last name is optional. So we have to null check here. And one way to do this is to use the null conditional operator to say, don't get the length if it's null. And all of a sudden, we got rid of a potential null reference exception. But it's a little bit smarter than this as well. I can also introduce a null check before this. So if person is null, continue to the next one. I hate this AI. I love AI, but not continue. There we go. That didn't work. Because I also have to check if person.details.lastName is null, then continue. So now what happens here is that it checks this entire path to that property, right? However, the compiler looks at person.details.lastName and determines that this is not null, and then therefore it will not continue to this next line here. But it's a little bit smarter than this as well. It can keep track of the null state depending on how you pass it into methods. Those methods can promise that they, in their turn, perform a null check. So for example, if I do argument, null exception, throw if null, person.details.lastname, what we've said now is that we will never reach this line if person.details.lastname is null. And it does this using something called null state static analysis. So the compiler keeps track that this method promises that you will not execute the next line if that is not null, or if that's null. So this is quite clever. Now, of course, if we get rid of this again, sometimes we might be writing code and we know that I've set this to an instance, I know it's optional, but I know better than the compiler. I promise that this is, in fact, not null. I've set this to an instance somewhere else. I loaded this previously, maybe this is deserialized from JSON, and I just know that this is not null. So I can use this thing called the dammit operator. So dammit, go ahead and get the length. I know better than you. However, we rarely know better than the compiler. And if we scroll down to this method here, I can also promise that null isn't null, and the warning goes away. So this is no guard. This doesn't solve all your problems. It won't guarantee that there's no null reference exceptions. It just hints the compiler that I forgive that this is null, right? So instead of calling this the dammit operator, it's the null forgiving operator. So I forgive that this potential object is not set to an instance. So of course, here with this method, I also determined that I could return something that's null, but then I have to declare that as well. This reference type could potentially be null. Or I can say, I'd like to return a new instance of something, and this here is a target type new expression. So if I do new and don't specify the type, this will look at exactly what I want to create. Now, being an IEnumerable, I have to create a temporary list, for example, or I can use yield return to say, create a new iterator and create a new instance of something that you've tracked to be the correct type. It's still giving me an error here, but the error is that I haven't set this required property called details to an instance. So if I use the object initializer, I don't want person. So now it's going to say that details is required. So I can create a new instance of that as well. Here we go. And I can set first name, new thing. I don't know what this is doing. I'm going to stop typing soon, and you should just trust me that this works. Come on. So what should have showed up here is first name, unless I have something, there's no target for, because I missed that. There we go. Let's try that again. First name is required. Phew, look at that. So now all the warnings disappeared. If you can type, this works a lot better. Promise. So now what happens here is that I use yield return so that I don't have to create a new temporary list unless someone tries to iterate over this, what's returned from here. I use the target type new expression, and I like this because the compiler can now figure out exactly what type I'm creating, and this will look at the person and create that for me. Requires less keystrokes, and if you type again correctly, it requires less keystrokes. And then it also told me that first name was required. And notice how that was actually a compiler error. If I don't do that, I can't even compile the application because it's telling me that you have to specify this. So anyone that used the object initializer before, they are now required to specify this because otherwise they might end up with a null reference exception. So what about if we'd like these things, such as, for example, last name? What if we'd like to get this as an error as well? What we can do is that we can turn on a feature when we compile our application to treat all warnings as errors. This is great. So we can go into the C's prod file and say, hey, I'd like to take all my warnings Because how many of you are looking at your warnings and fix them? No one. One person. That's amazing. I do that when I create new projects, but if I go into an old one, I just ignore it. Now I'm kidding. What I like to do is I like to turn this on, check that in, and just go on vacation. And then someone else fixes the problems. Doesn't happen. Means you don't have a job when you come back. But when we turn this on, it turns all warnings into errors. And if we have, for example, we can even specify that we'd like to turn these nullable reference exception warnings into errors, only them. So this language feature, while it was introduced in C#8, they introduced the required keyword in C#11. They introduced the target type new expression in C#10. So they continuously improve upon the features they've added before as well. Now let's talk about a couple of features from C#9. I'd like to specifically show you record types, which is a new way of creating reference types. We have the init-only setters. I didn't talk much about this, but if I just jump over to this code base here again, instead of having set, we can have init. I'm going to make this optional again. And what happens when we write init here instead of set, you're only able to set this once. So it's effectively immutable. Once you've set this to a value, you cannot change it. And you want immutability for multi-threaded applications because cross-threading and being able to change the state is not a good idea. In C#9, they introduced this concept of a top-level statement or a top-level program. This is a completely new way of writing your program.cs file, which ultimately allowed them to introduce what's called minimal APIs, which I'll show you a couple of examples of in a bit. Now, with C#9, they introduced a whole lot of patterns and improvements to pattern matching. That's what we're going to spend a little bit of time talking about, because this is also one of those language features has taken inspiration from other programming languages like Swift, Kotlin, Java, and whatnot, a lot of other functional programming languages as well. And there's the target type new expression that I talked about. And then there's a whole lot more. They've introduced a lot of features in the compiler that are more specific to certain types of applications, and if you work with lower level programming, or do very specific things. So you don't have to use all the language features. And then that's one of the things that a lot of developers think, that once there's a new version of C#, I have to go back and refactor my entire code base to use this new thing. Just take one of the favorite features, apply it to your new code, or when you go back and refactor one piece, you don't have to refactor everything. But then again, that also, some of these things come with analyzers. So when you actually do upgrade .NET, it will give you warnings. And if you treat warnings as errors, then you can have a problem. And you guys go around this infinite loop of issues. So let's spend some time talking about pattern matching instead. Now, pattern matching is a concept that's been around for a very long time. We can look at objects in terms of what color is that fruit? Is it edible? How do I lay something out, or is this looking in a certain way or not? We've always been able to do this. Using code like in C#1 through 6, we could say, give me the type of the object, compare that to the type I'm looking for. I then have to typecast this into the correct type before I pass that into a method. Super simple. I sometimes write code like this still, and it works. It's nothing wrong with it, but there's better ways to express ourselves. So with C#7, they allowed us to use a similar approach, but using a switch statement. So here, or a switch, is a normal switch. So I can use the object as an input to my switch, and then write cases where I say, if this is this type, the compiler already knows that this is the correct type I'm looking for. Therefore, I don't have to do any typecasting myself. And I can, of course, use the default then as well, because it could be any other type of object as well. Now, as of C#7, which is quite old now, I didn't write pattern matching using a switch because it didn't really make any sense. It was a lot more code to solve the same problem, which I could previously solve with just a couple of readable lines. However, when they introduced this concept called switch expressions, this is making it quite interesting. So here, I'd like to get a result based on this object, and I'm going to create patterns for this object. So now what I can see here is that I'm going to fill this with expressions or patterns as well as expressions. Looks like expression-bodied members. So, for example, I can say, well, what about, I'd like to get a result based on the input. If this user is still active, and it's an instance of a user that's still active, I'm going to return account is active, For anything else, I'm going to return account is disabled or user not existing. The discard or underscore means that it's null, or could be null. It could be anything other than the user. It could be an instance of anything else that derives from the same type. And of course, this is what's returned from that match when there's a match on your object. So what we can do is that we can take anything, use pattern matching to determine what the contents is and what it looks like, and then produce a result based off that, right? And in C#, there's a lot of patterns, and again, they've taken inspiration from other programming languages as well. You don't have to remember all of them, but the most basic one is the type pattern. Looking at, is this the type I'm looking for? This will also ensure that it's an instance of that type. So if you go back here, user will also determine an instance of a user. We have positional patterns, which is used when we deconstruct an object. There's a property pattern to check property values. There's a tuple pattern or tuple pattern. There's a relational pattern. So you could, for example, say, I'd like to check if the user has not logged in for at least 30 days. There's a way to write a pattern for that, a very simple expression. We can conjunct and disjunct patterns by saying and or, just like in normal if statements. There's ways to write patterns for lists. There's ways to group them. But if you start grouping patterns, that's a little bit of a code smell that the patterns are becoming a little bit difficult to maintain and work with. And we can negate any pattern. And when used together, all of these end up being a recursive pattern. So let's jump over to Visual Studio instead. And we'll take a look at a couple of these here. Before we look at pattern matching, I did mention that I wanted to talk about records. Who's seen a record before? Almost all of you. So just to recap, a record is a simple way to create a class, but it gives you value-based equality, and it's immutable. And it's also a very nice, concise syntax. So everything that we have in the primary constructor of the record, like I have here, will be exposed as a public property, and that cannot be changed. So when I create an instance of a record, just like I do with a normal class, it's a reference type. What about if I want to change the value of, for example, test dot, let's say, number of attempts to 4? I can't do that because it's immutable once I've created this. We have to dereference it to say, hey, I'd like to get the test with a slightly different value. So then we use this with keyword to say, I'd like to copy this, and this will copy the values on that object. If you have a list available on your record, for example, it copies the reference to the list. It doesn't copy the values of it, like when you do like it's not a deep copy. All right, so now that I have this here, I'd like to write some patterns for this. So here, as you might have noticed, this test result is an abstract class, has two subclasses, failed and passed. I could write a pattern to say, hey, I'd like to get the outcome of what this test result is. And we introduce a switch statement or switch expression. So now what I can do here is fill this with patterns. I could say, if this is passed, it's passed. If it's failed, well, it's probably failed. And for anything else, I'm not going to throw an exception. Inconclusive. So the underscore will capture or match on anything else. It could be any other type that inherits from the same base class. It could be null or whatever. A little bit of a gotcha here as well is that if I use what's called a var pattern, so I could say var test, this will actually use something called a declaration pattern. So it will declare whatever was matched on as the local variable of test that I could then use inside this context of what I've matched on. So I'll get test dot, for example, and I'll get all the properties available on that base class. However, when you use the var pattern, that also matches null. So it's the same as using a discard. It matches on anything. So just be careful, because var could then potentially, using this here could potentially throw an exception. So you'd have to check using a null conditional operator, for example. Anyways, what we can also do is that I could negate a pattern to say, well, if this is not passed, The compiler will now be smart enough to know that that's the same as failed, because that's the only two different alternatives that I have. So therefore, it knows that I've already matched on something, and I will never be able to match on the next one. So only negate patterns when you're, for example, using not null or not something you're looking for, but maybe not in this case here. How about if we'd like to check a property? I could say that, let's get rid of not. I could say this has to be passed, and the number of attempts has to be more than 1. And it cannot be more than 10. Now what happens is that recursively, this is a recursive pattern to say it has to be passed, an instance of passed, which has to have a property that is between 1 and 10. And of course, if we were to negate this, who knows what this means? We can write patterns that make no sense at all. Like we can with any code that we write, we should be careful about how we express ourselves. But I reckon that pattern matching will help us write code that more resonates with the rest of the business when we talk about certain things that we want to look for, or if we write really complex patterns. So now, and we can use not anywhere we want. We can exclude values using or, and we can write really complex patterns here as well. What I want to show you as well is that we don't have to use this with the switch expression. So what about if I were to, I'm going to copy this here, or cut it out, and say, hey, if test result is this thing, I'd like to capture this. Actually, let's make it even more interesting. Let's take the method call and say, hey, I'd like to call this method, and if what's returned from this is passed, I'd like to capture this as a local variable. Then I can say, I'd like to get the passed test. And now I've declared passed test as a local variable of the type passed inside that context of that if statement. So I can use this with whenever I call a method. Don't have to call it on the line before. Don't have to do any typecasting. The compiler already knows what type it is, right? So this is where I think patterns makes a lot of sense. I also want to say that you can use this to say, if you were to do this, this means that it's not null. It's an instance that has properties or values on it. And this is not the way to do a not null check, because it makes no sense whatsoever. It would be better to say this has to be passed, meaning it's set to a reference. So I think patterns are evolving quite a bit, and we're going to look at some more patterns in just a moment where they've also added patterns for lists as well. But before we do that, I'd like to talk about a couple of things from C#10. So while they keep adding additions to patterns, you can trust Visual Studio, Writer, or VS Code, or whichever IDE that you use to help you along the way to determine how to simplify your current code to convert that into something that uses pattern matching instead. But again, the code could become a little bit less readable as well if you're not careful. All right, so with C#10, they introduced record structs just as record classes. We can do the same for structs. I don't know many people using structs unless you write really high-performance code. They improved some structure types. There's a global using directive. There's a file scope namespace declaration. And they've extended the property pattern. So what happens, actually, let's jump over to Visual Studio and talk about 3 of those things. So as you might have noticed, if we go into this test result class, notice how I have namespace, and then I have Azure Dev Summit, and then semicolon at the top. That means the whole file belongs in this namespace. I don't have to indent the entire thing in a namespace. Appending global in front of a using directive means that this here is going to be used inside the entire CS prod file, which is quite nice as well. And the third thing was the extended property pattern. So what about if I'd like to check that this here is set to an instance, I'd like to check the test date, and I'd like to say that, let's say that the day of year is exactly 10, whatever. So prior to C#10, this here would not perform a null check. What you'd have to do instead was write some really ugly code looking like this here, where you'd have to do this to ensure that this is an instance that has a property that has an instance that has this value, but now it automatically performs a null check here. So when accessing day of year, it automatically null checks that property as well, which is nice. Just small things, small additions in the compiler that does a really great difference. Reduces the amount of ugly code we have to write, and makes our lives easier. So there's some improvements of Lambda expressions as well. For example, we can now use attributes in our Lambdas, and they're inferring the delegate types. I'm going to show you an example of that as well. We can do constants in interpolated strings. And there's a few more things in C# 10 that were quite interesting as well. Now, in terms of inferring the delegate type, this is nice, because now I don't have to write this funky piece of code anymore. I don't have to specify exactly what func is returned from this anonymous method. Instead of doing this like I had to do in C# 9, I can simply say var parse, and then I have the declaration of my anonymous function. And it just determines exactly what Lambda to use here. And also, in terms of improving our Lambdas, we can now use attributes in Lambdas as well. And this here is a little bit of a snippet from a minimal API. We can very easily create ASP.NET Core applications in a very tiny format, and simply here saying that I'd like to map /ID to whatever anonymous function this is that produces some code or runs some specific code here. And adding more language features to this, or adding more functionality on Lambdas, means that we can write more fully functional minimal APIs as well. So while the concept of a top-level statement was introduced in an earlier version, in C# 9, they continuously improve upon this as well. So we're starting to approach the current version of C#, but before we do that, we're going to talk about C# 11, where again, they introduce a couple of more patterns. We can write patterns for lists to determine the contents of a list. We can slice off portions that are available in a list, and also use this with spans. We can use name of parameter. They're now caching delegate types for static method groups. The required keyword was introduced in C# 11. So prior to this, as C# 8 introduced a nullable reference types, there were quite a few versions where you had to write some really ugly code to ensure that the compiler didn't complain about things not being set to an instance, which then again led to potential null reference exceptions. But being able to hint this to the compiler means that we can now try and track these problems before they occur. So very simple. They also introduced raw string literals, static abstract members and interfaces, UTF-8 string literals. So I could simply say that, hey, I'd like to take this string literal and represent this as UTF-8 in memory. And why would I want to do this? Because C# and .NET is traditionally UTF-16. And if something comes over from the web, which is UTF-8, that has to first be converted into UTF-16 for you to do a comparison. Now, you don't have to do conversions between UTF-16 and UTF-8 anymore when we have this concept of using UTF-8 string raw literals, or UTF-8 string literals. There's also generic math support, generic attributes, which is something that I wanted since I did ASP.NET APIs way back in the day. I don't understand why this took so many years. And then what's interesting, because C# is open source. And there's this language feature called parameter null checking, which was added to the language. And then they decided to remove it. What this did, it doesn't make a big difference because they removed it and it will never come back to the language again. But the idea was that you add double exclamation marks, and it's really like saying, damn it, perform a null check. If this is null, throw an exception. So what this did was that it generated code to perform a null check and throw an exception if that was null, which is kind of a nice idea, but it's very intrusive, and it just adds a lot of ugly exclamation marks all over the place. Like, we don't want C# to end up looking like this in 10 years, right? That would be very terrible. So this was removed from the compiler. However, they came so far as they implemented this in the compiler. They were going to release it. The whole .NET repository and GitHub refactored their code base to use this. Then they removed it, and they had to revert all their changes in the .NET repository. So with that being said, I don't use any experimental compilers because you don't know if they're going to remove the language features or not. But that also shows that they listen to community feedback. If you have any language features that you want to introduce in C# or get some ideas as to why they're added or understand the reasoning behind some of these things, you can go on GitHub and read about them. Or you can also add their opinions. Developers always like to hear opinions from other developers on the code they write. So we're going to talk about the list patterns. And one of the things I really like here is that I have this list of data here. It's actually my family's names. And I'd like to create a pattern to say, I'd like to produce a result based on the data that I have here. And the first thing I'd like to check is if the first name is Filip, I'd like to slice off the middle portion as long as it ends with Elise. What this will give me is a new collection, or a slice off that initial list with 2 names in it. And I can access that inside in my expression. I could also say I don't care about what the first element is. It could be null, it could be whatever string. The second one has to be Sophie, and then there could be more elements or not. I could also say that maybe it's empty, or there's a lot of elements, give me all of them. I could say that it's null. It's not set to an instance of a collection. So I like the list patterns, and there's a couple of, let's see here, let's jump over to Visual Studio. There's a lot of good use cases for this. So, for example, here's another example of doing the same thing, but I use hexadecimal numbers because it makes me look a little bit like a hacker. So I have a span of a byte here. A span is simply a way for us to represent any arbitrary memory. It could be managed, unmanaged memory, managed on the heap or stack or whatnot. And what I'd like to do is to say, hey, if this starts, it's an instance of a list, and it starts with 0x1, give me the middle portion, and it has to end with this, this value as well. Same idea. And same idea when I slice off something. I could say, give me everything at the end, for example. It has to start with 0x1. There has to be an element followed, and then give me the rest. So this could be verifying the header or the signature or the payload or something similar. And being a span, slicing off this here will actually give us a span of T as well. So it won't create a new collection. So depending on what type this is, performing a slice like this here could produce extra allocations, but when it comes to spans, there's no extra allocations necessary. And finally, the last pattern that they introduced is the span pattern to say that if I have my name represented as a span, any string can be represented as a read-only character, read-only span of a character, which is simply an array of characters somewhere in the memory, doesn't matter. But performing any operations on this is performed on that same collection in memory, so it's not doing any extra allocations. And this here, with the span pattern, allows us to implicitly convert back and forth between the string and the span of character, which is nice. All right, so let's see here. We have raw string literals as well. Tiny thing, but basically we can say I'd like to create a string with triple quotes, gets syntax highlighted in Visual Studio. So just notice the triple quotes here. We can write XML and HTML and whatnot, and it looks like PHP did 25 years ago. It's a nice way to include JSON or XML inside our code as well. And we can also interpolate this here to say, I'd like to interpolate this with its value. Now, I have an interesting example here of serial allocations and using this UTF-8 string literal that I've talked a little bit about. So let's take a moment to look at this example here. So I have my name here represented as a UTF-8 string. This is really just converted into a read-only span of a byte. It's not a character because a character is UTF-16. What I'd like to do is I'd like to find the space of this here, which is a quite quick operation. So to do that, I can find the space by doing payload.index. Find me the UTF-8 space. What I'd like to do now is to slice off the first name and the last name, and I'd like to do that without producing any extra allocations. I can do this using link, but that is a lot heavier than it has to be. So what I can do is I'd like to get my first name, and to do that, I can say, give me a slice where you take everything up until the space. And then after that, what I can do is to say, give me everything after the space until the end. And this here produces no allocations whatsoever, except the references on your heap, but that's like not really, doesn't really matter at all. It doesn't have to copy any memory over when doing the string manipulations or copying the data over. And of course, it's simply just pointers, right? It points to the correct elements in your original string. They do this heavily in .NET, and this is one of the things that is making the performance improvement so drastic in upgrading .NET to the latest version of .NET, which is also why you really always want to upgrade to the latest version of .NET, because they do this in more APIs, they use it more internally, so it's just a really good way to keep our application performant. All right, so now let's talk a little bit about C# 12. In C# 12, they introduced primary constructors, same concept as with record types. But the difference is that they add this to classes instead. Instead of requiring us to have a record that's simply an immutable class, they allow us to do sort of the similar approach on classes, but slightly different. They also add the collection expressions and the spread element. There's interceptors, which is great for source generators. There's optional parameters in lambdas, again, making it better for minimal APIs. And alias anytimes, inline arrays, they're kind of more suited towards very specific scenarios. And ref-read-only parameters. And probably my favorite feature, so you know there's this obsolete attribute you can add to your code, which tells developers that don't use this because I'm going to remove this in a newer version. There's an inverse of that I add to all my code, and it's experimental. So you have to opt in to using the code that someone writes. I love to add this to my code. My coworkers don't appreciate it. I'm kidding. So let's actually jump over to Visual Studio again and talk about a couple of these features. So I'd like to show you the collection expressions. Let me just minimize this here. So the collection expressions is a way for us to very simply produce a collection. Think of this as the target type new expressions, but for collections. So here, I simply say, I'd like to create a new collection, like this, fill it with this data. The compiler will now figure out what the target is. So if this is a span of a byte, it will create the most suitable type for that. If it's a byte array, notice how I don't have to do anything, but it just figures out exactly what to create for me. But to make it interesting, let's have a list of a byte that I've created here. The compiler knows how to create this type. Also a byte array, which is something different. I'd like to create a new collection that contains my payload and my checksum. The way to do this is to use the spread element, or in the very early days called a spread operator, but it's not an operator, so they remove that naming and call it element instead. So what I can do is that I can say, I'd like to take everything from the checksum and spread that across. Actually, it should be other way around. We're going to spread the payload at the front and then append the checksum at the end. What happens here is that it takes everything that we have inside the payload, adds that to the first portion of that collection, takes the checksum and adds it to the end. You're not limited to 2. You're not limited to using the same thing once. You can use it as many times as you'd like. Don't know why you would want to do that, but it works. And the collection expressions are a very nice addition to the language. I use them a lot. Now, for the primary constructors, much like the naming suggests, it's a way to define a primary constructor on a class. Looks very similar to what you have with your record types. The difference here is that this does not expose this as a public property. All that it does is to create an internal field, or a field inside that class, which is private to itself. If you want to expose this publicly, I can introduce a iUser repository, and I can initialize this. Let's not allow anyone to set this to anything else. I could simply do that. So now I've introduced a primary constructor that requires us to set this. And if you're like me and you have services and controllers that have a million different dependencies, I really like this because I don't have to create that backing field myself. I don't have to add the constructor that sets the backing field myself, and it's just automatically injected by dependency injection. And if I want to expose this publicly, I can very easily do it like this here. Otherwise, just use it inside methods that live inside this object or this class itself. All right. So one thing, I briefly just mentioned this, but there's this concept of interceptors. If we just look at the highlight here of what's in C#12, there's this concept of interceptors, which is a way for you to intercept calls to a method. It's sort of like saying, someone can come to me from somewhere. As soon as you call a method, run my code instead. Kind of the inverse to go to. It's great for source generators because you can replace code in runtime. Or in compile time, sorry. So when your code compiles, it can look at your source code and it can replace code with some interceptors that intercepts your calls. So you won't write them yourselves. I've had demos of this in the past, but since no one writes them themselves, it's just a little bit unnecessary. So the collection expressions are really great. They allow us to very easily create collections, and we can use the spread element to create new collections as well. And if we just take a quick look at the primary constructor again, for a normal data class like a user here, it doesn't make a lot of sense to have a primary constructor because this here doesn't expose anything publicly. So for a user, I would much rather use a record instead. The only problem with a record is that they build upon value-based equality. And Entity Framework uses reference-based equality, which means you can't use records with Entity Framework yet. So if I decompile this, maybe you can't see this, but it simply introduces a backing field with one primary constructor, which is kind of the problem here, right? So if we'd like to use for a user or data class, we don't want to use a primary constructor on a class. And they introduce default parameters in lambdas, again, making it better for us when building these minimal APIs. And we can alias any type to say that inside my entire project, if you use the thing called dimensions, this simply points to a tuple. You don't have to create a class or a structure yourself. I guess I can just show you how these interceptors work really quickly as well. Think of this idea here. I have this logger which calls log internal, which throws an exception. But when I compile this, I have something that looks at my code and knows that I'm going to replace everything that calls log internal. The implementation sort of looks like this here. You have an attribute called intercepts location, which points to exactly that line of code. And when you run this, it will run this interceptor instead. So whenever that method is called, it will be intercepted by this here. This here could be coming from a NuGet package that you don't know about. But you have to opt into this happening. So don't think that you can pull down any NuGet package and just replaces your calls. You have to specifically go into your project file to say, I allow this package to create interceptors for my application. Unless it's in ASP.NET Core or internally in ASP.NET Core, because this is heavily used inside ASP.NET Core internally. If you, for example, what this text here says is that if you perform an ahead-of-time compilation, it will use interceptors for when creating the request delegate generators so that it can be very performant in terms of how it handles requests. But you won't write these to yourselves. You'll just rely on interceptors from source generators that you've opted into. All right, so we're up to the current version of C#, C#13. And again, like we have 10 minutes left, and there's not a whole lot of features left in C#13 and 14 that are groundbreaking. But let's quickly go through a couple of these here. So one, they've introduced a preview feature that you can opt into if you're on an older version of Visual Studio or the current version of Visual Studio. The field keyword allows you to reference the backing field of an auto property. There's params collections. There's a new lock object, implicit index access, overload resolution priority, more partials. In C# 14, they're going to add partials for more things, like partial constructors and partials anything. And this is to make it easier for source generators to create code that's more suitable for your applications. So the field keyword, if I have this auto property, I can reference the backing field of this property instead of having to introduce that myself. And this is good if I want to clean it up before setting the backing field, or if I want to clean it up when I return it. So that keyword will work if you enable the preview features of the compiler. And the way you do that, it's quite simple. You go into your csprod file. There's a lang version called preview that you can turn on or set to 13 or 14 or preview or latest. And that will just enable that compiler. I'm not going to update now. It's probably not the best idea. You can set this to whatever version. And a little hack here is that if you're on a very old version of .NET, you can still go ahead and set the lang version to anything newer than the .NET version you're currently on. And the compiler will attempt to compile your application using the latest compiler, and you get access to language features that shouldn't be available in your .NET version. But as long as you don't touch anything in the runtime that requires a runtime change, you'll be fine. Unsupported, but may work. So what's interesting with the field keyword is that this is actually a breaking change. They don't introduce breaking changes in C# and the compiler so often, which is why it's now an opt-in and preview feature to get people accustomed to the idea of using this. So what about if there's already a field called field in your class? You can use the keyword escaping character to reference that instead. Just like if you have something before async and await was introduced, you could add the @ in front of them. But as of C# 14, this will be, you're required to do this. Params collections allow us to now use params with any collection types, and this language feature builds on the collection expressions. So they had to add collection expressions first before they were able to add this language features. So simply params in front of any collection type. This works with spans, read-only spans, arrays, any enumerables, and it will try to be clever enough so that some of them take precedence over others. However, sometimes if there's a human compiler in here, you might notice that you can see here that I use the collection initializer here, and I can also use the normal just comma if I want to do that. So I can either pass it as a collection or pass it as separate elements. However, this here is ambiguous. So the compiler won't know when you're calling the method using these two alternatives, it won't know which one of these two to use. So therefore, they introduced another really nice feature to determine the overload resolution priority. So you can say that if there's ever something that could be ambiguous, choose this version instead. So if you're introducing a new alternative version of something in your APIs or if you're a library developer, then using the overload resolution priority is quite nice. A small feature is, or not a small feature, but a small change that you can make is to use the new lock implementation. So by simply using the lock type instead of an object, who's using lock and as a sync root or using parallel programming? No one, a couple, all right. So this here is a lot better internally. There's better thread synchronization. If you ever have to do locking, try not to, but it's really, when you have to do it, it's like there's no other way. Then you should really use this new way of lock in .NET 9, which is in the runtime as well as a language feature of C#. If you're writing source generators, or you can mark things as partial, for example, we can have partial properties, partial methods. We are going to be able to have partial events, partial constructors. So you can pretty much mark anything as being able to be generated by source generation. The last one in C# 13 is implicit index access. So the hat symbol means reference the last element. Here, I'm creating a new collection, or I'm creating a new thing called data, which is a class. It has a, I think I have this in Visual Studio. Let's see if we have this. Otherwise, I'm going to show something else that's actually more relevant. Oh, let's see here. Actually, let's do this. What it allows you to do is to point to the last element. So if you have an object that already has an initialized array, I can point to the last element, set that to a value, and I can go ahead and point to the second last, third last, fourth last. So it kind of implicitly just allows you to reference elements inside that array, which is quite nice. All right. So before I jump over to Visual Studio again, I thought I had this in Visual Studio, which would make a little bit more sense. We have 4 minutes to talk about what Matt is going to talk about for an hour tomorrow as well. So please go to his session as well, because there's a lot more details to talk about here. C# 14 is the next version of C#, and it's going to be released in November this year. The field keyword is no longer going to be preview feature. There's going to be more of a first-class span type, so it's going to do implicit conversions to spans as much as possible. So it's going to be try to be more, allowing you to use more performance-focused types as well. There's the extension members or extensions everything that people have really wanted for a very long time. We can use modifiers on lambdas. There's more partials. You can use partial constructors events and partial members, and null conditional assignment. So let's see here. Extension members. I have this static class. Extensions always have to live inside a static class because there's no instance. There's no instance of what you're extending, all right? So this is going to look a little bit complex, but what I have here is an extension for anything that's of a type or of a number. The extension will have a reference to that number or an instance of the number. And I'm going to add the method add to everything that could potentially be a number. And because this is a number, so this is the generic generic math support added in C# as well. Looks very complex, which is why it's so fun to show off. But basically, it's not very, let's see here. We can go ahead and say, if I have 10, I can now call the add 10, and that's actually my extension because I can extend anything. So basically, I just extended an integer because int is a number. So the difference is the syntax of writing extension methods. So instead of having those old static where you have this parameter passed into the method signature, the syntax is just a little bit different, and it looks a little bit better. But Matt has a lot more details on why this is important and how this works internally as well. All right. So extensions, everything is finally coming. Didn't make it into C# 13, but we're finally going to see that in C# 14. And here's a little bit of a more simple example. I have a user extension which extends user. It adds a property which you couldn't do before with extension methods. So now I can extend it with a property value as well. I can extend it with another method that uses this property as well internally. It's a very nice addition, I think. And the syntax is a lot nicer as well. And again, improving upon how we perform null checks and building upon the nullable reference types from C# 8. This here is the null conditional assignment. What this will do is to say, I'm only going to set name to a value if that user is not null, which is also a very nice addition. But again, I think if we start using question marks all over the place, the code is starting to become a little bit difficult to read. So use these features with cautions. And after a talk like this, someone always asks me about union types or union members or unions. There's now, you can go ahead and read up on this discussion they have. It's coming. It's not going to make it into C# 14, probably not 15, maybe 16, who knows. But you can participate in the discussion. It's coming. They're just ironing out all the details. And after C# 14 is done, hopefully they're going to spend a lot of time building this because it's a feature that's been requested for a very long time. So C# is still super relevant. It's still being updated. Don't feel like you have to go back to your work and just refactor everything to use everything from C# 13. But hopefully this gave you a little bit of an inspiration as to where you can apply some of these practices, some of the patterns using the nullable reference types and records and all of the other stuff that we've looked at as well. And if you like listening to me, I have quite a few courses on Pluralsight, a lot on C# and .NET in general. So thank you so much for coming. On the way out, there's a little box. Put a green thing in the box. If you didn't like it, just go skip the line and go and get a coffee. All right. My name is Filip Ekberg. Thank you so much for coming.